Good morning, good afternoon, good evening, depending on where you are in the world. Welcome to this class on how to use mapping and geospatial data in Autodesk software. My name is Ian Robinson and I'm the infrastructure consultant for Greytech. I travel around from my base here in the UK helping customers get the most out of their infrastructure design and BIM related software. This includes training, consultancy, presentations, bit of social media, usual stuff. My main focus is Civil 3D, Map 3D, GIS being my background, Infoworks, Recap for your point clouds, Navisworks for your federated models and your clash detection, and also BIM 360. There are 4 pillars to what we do here at Greytech: create, simulate, fabricate and manage. We work with the Autodesk portfolio and our own Power Pack enhancements to aid the creation of construction and manufacturing deliverables. We then combine this with the use of our simulation products to verify those deliverables, and this enables us to drive them into the fabrication process, and we can then manage them deliverables too. And now with our CDE products linking to internal and external platforms. This class is in the create phase of the project and talks about data and procurement more than anything. We'll use a little bit of Infoworks, AutoCAD, Map 3D, Civil 3D, some Microsoft ODBC. All of this data can be stored in BIM 360 and our own products OpenTree. So go and see the OpenTree classes and the BIM 360 classes on this platform. Here are the most common questions that I get asked about mapping. So let's start there. Where do we get mapping data from? That's the most common one. How do I use mapping data? And these are usually from AutoCAD users, AutoCAD LT and Revit users. We get a lot of questions on that. How old is that map? The data you're putting in, how old is it? How do you use building height data? Can I get building height data? And I also hear a lot of people say, I don't need all that stuff. I've got a whole load of maps in DWG format on the server. I just use them. Let's start with the first one. Where do you get your mapping data from? Well, it all depends on who you are. If you're a local government or central government department or police, fire, ambulance, etc., then you get yours through the PSGA, the Public Sector Geospatial Agreement. This replaces the PSMA, which was the Public Sector Mapping Agreement. It replaced it on the 1st of April 2020 in England and Wales only. For Scotland, you're still on the OSMA, the One Scotland Mapping Agreement. For now, that may change soon, but if you visit the One Scotland portal on the OS website, that will give you information up to date. For Northern Ireland, visit the Ordnance Survey Northern Ireland or the Land and Property Services, LPS. I don't think they actually have a public sector mapping agreement at the moment, but please feel free to correct me on that. For Ireland, visit the OSI or the Ordnance Survey Ireland and their National Mapping Agreement, the NMA. All of these are clickable links if you download this presentation. Things are changing at the OS and there will be a new OS data hub for you to access all of their products. Now, if you work in any of these organisations, you will already have a dedicated department, usually the GIS department or the Geographical Information Systems department. They control and manage all of the data. Just go and speak to them. If you're a contractor working on behalf of any of the above, then under the old PSMA, you can get a contractor's license to use their data without charge and under the terms of that license. It remains to be seen what the new agreement will offer, but the Geospatial Commission, which is part of the government's Cabinet Office, has stated that there will be greater freedoms to share data. So unless you're already in this possession of one of these new agreements and you know better, let's just wait and see what actually transpires in reality. Large organisations such as energy, water, communications already have a GIS department or a geospatial intelligence department. The data is already there, and again you can use it in the Autodesk software. They usually get their data directly from the OS. For contractors of smaller private organisations, they can purchase their data direct from OS partners. And there's a list here, the 4 on the right there is just a small selection of the many partners out there that will supply the data for you. We're not affiliated with any of them, they're just examples. The educational sector, you're well looked after by EDINA. Digimap is an online mapping and delivery service available by subscription to higher education and further education establishments. There's an additional Digimap for schools for lower down, I don't know what the term is, lower down the scale, younger children, that's the word I'm looking for. Digimap for schools for younger children, and these guys, they're up in Edinburgh, they're doing a fantastic job, they produce some great products. They're actually doing some free access as well during the COVID crisis. Again, these are all clickable links, you're welcome to click on them if you download this presentation. The estates department for educational sector, though, that's a different thing. That's a commercial or a commercial system, so that really you've just got to act like a private organisation when it comes to licensing. So again, go and buy the data directly from the partners, these partners here actually. For private companies, you just go direct to the OS partners and purchase it. Just to give you an idea of how much it's going to cost you for an area this size, so a project this size here, it'd be less than £100 for the latest and the highest quality mapping product, which is called Master Map, Ordnance Survey Master Map. You can get it in CAD and GIS formats, but I'm going to tell you to get it in GIS formats. If you factor that sort of cost into your bidding processes, you can get a lot of data, you can make better decisions much earlier in the process. The next question would be, which Autodesk products can I use the geospatial data in? Well, let's have a look at the two main platforms, which is AutoCAD and Revit. If you have the AEC collection, you have all of them. You've got AutoCAD, you've got Revit, you've got all sorts, 3ds Max, etc., Recap. These are the products you would use them in: AutoCAD Map 3D, Civil 3D, and Infoworks. And of course, if you use these products separately and you don't have the AEC collection, but you have any of them products, then they will work with geospatial data. You have Revit as well. You cannot use geospatial data in Revit. You get that obviously in the AEC collection as well, but if you have Revit separately or Revit LT, you can't use geospatial data with that. Yes, I know you can take a DWG and you can link to it and see the data in there, but that's not what we're talking about here. If you have AutoCAD or AutoCAD LT, and again, you cannot use geospatial data in either of these. However, since 2019, all AutoCAD users can download AutoCAD Map 3D at no extra cost. It's basically AutoCAD with mapping functionality. So it's exactly the same as AutoCAD, but with extra functionality. So just a very quick recap. If you've got Map 3D, Civil 3D, or Infoworks, or you're in the AEC collection, you have that, you can use geospatial data. You cannot use it in Revit or Revit LT, nor can you use it in AutoCAD LT. If you have AutoCAD, just download the correct version of AutoCAD, which is AutoCAD Map 3D. Next question. How old is that map? A little bit of a cheat here. I rarely hear that from people, but it's the one that I ask all the time. Every time I see a drawing with mapping data in it, I ask, how old is that mapping data? Is it up to date? My record so far, when I inquired, I asked somebody how old the mapping data was on their modelling of coastal erosion, and the answer was, I'm not sure, but it's at least 7 years old. Now in that particular case, I knew they had a public sector mapping agreement. I also knew they had ArcGIS, which is Esri's mapping application that holds and manages all their geospatial data. I also knew that the Ordnance Survey were providing them with an updated mapping product every 3 months, so they were well up to date with it. On top of this, they were using what was the precursor to the AEC collection, and they had all the tools to access the up-to-date mapping data. So you've got to ask yourself, is this you? Do you have a load of old mapping tiles in DWG format that you probably, if you do have that, you probably have the original data too. And if you have the original data, why not use it? Next, I get asked this quite a lot. Does it have building height data? And for years I would always say no, the Ordnance Survey don't do building height data, it's difficult to do, and I came up with all the excuses. But now I can say yes, it does. I'll show you how you can use that information in your mapping product, in your in Infoworks and AutoCAD Map 3D and Civil 3D. And lastly, you have a load of old DWG format tiles on your server. I refer you back to the question of how old is that map? Also, do you know where the data came from? I mean, if it is 7-year-old, for example, you'll look rather silly planning a project on a base map with features on it that don't exist anymore, or in a space that was built on 5 years ago. If you have a load of tiles, then most businesses and organisations use a piece of software, maybe one called Interpose or FME from Safe Software, to create them DWGs. They're creating a snapshot in time of the data, and it might not be time stamped. For example, if somebody opens and edits or overwrites the file, it has the wrong timestamp on it. Anyway, if they made the DWG, then they will have had the original mapping data. Now, map data comes with all sorts of attribute information that is missing in the DWG. So, for example, your DWG looks a little bit like this, and maybe you want to have a coloured map with a bit more information in it, or maybe you want to colour it based on the attributes. So, for example, building height, show me where all the tall buildings are, or just show me the buildings. It's much better to use the latest data and make that data work for you, and I'll show you what you can do and how to get the most out of that data. Okay, let's just have a quick look. This is AutoCAD, plain old boring AutoCAD, or is it? It's actually AutoCAD Map 3D. So if you're an AutoCAD user, instead of downloading AutoCAD, use this product instead, because it's got everything that AutoCAD has. It even looks like AutoCAD, but it also has mapping functionality. And if I just go into here and change it to my Map 3D interface, and there we are, we have this mapping functions in here. Of course, all the AutoCAD commands are still in here as well. They'll carry on working, and you can, using the CUI command, if anybody is used to using the customizable user interface, you can change it to however you want. We've also got a thing called the task pane. Now, I've loaded a template here called a master map template, which just has everything set up in terms of the layers and what have you. If we were to look at the layer manager, you'll see I've got all the layers already set up, and that's pretty much it. The other difference between AutoCAD and Map 3D is that Map 3D works on the British National Grid. And you can see down there that there is no coordinate zones. It'll work on any coordinates in the world. And we can go to a library here, or you can just type map CS assign, and we can assign a coordinate system to it. So if I was to type in British in the search, we should have one in there that fits us. There's the British National Grid, so I'll use that. Now the beauty is we've had this function since about 2014, if I remember rightly, the ability to put aerial imagery in your maps. Now in AutoCAD, because you're not on a coordinate system, yes, you can use it, but you have to go and tell it where everything is. Whereas here, we've got a map of everywhere. Doesn't matter where you go. And it's already set up. Now that map should match any geospatial data that I bring in. So let's have a look at bringing in some geospatial data, and I'm going to use the command map import. We can import data directly into here, and it converts any geospatial data into lines, arcs and circles for AutoCAD use. However, it's not ideal because these files can get quite big, so before we've done any drawings we're up to 7 meg, and of course this is quite a small one here. Now look at all the file formats that we can import. Google Earth, Map Info, Esri, GMLs, Geographical Markup Language, SQLite. Incidentally, that's what Infoworks runs on, SQLite. Now when they buy the data direct from the OS, they send it in a GZ format, which is a compressed GML, or Geographical Markup Language. So we can work with that directly, and in fact I'll just very briefly show you that. But the reality is, if you're going to buy this data from any of the OS partners, they're going to offer it in probably a shape file is the most common that they will offer. But you can get it in shape format, or you can actually get it in CAD format, but I'm going to tell you not to do that because we want all the attribute information. Now just to show that you can work with the raw data, I'm going to pick the raw data, hit OK, and we can import this data directly. Now we can either import it by drawing layer, or we can just import it all onto one layer and use the task pane to style it, and that would be probably better and quicker. The key thing is you must bring the data in. Okay, and I'm not going to bring all these layers in actually. I'm going to deselect them all and just bring in topographic. So I'll do topographic area and topographic line. We could also bring in the text as well, actually thinking about it. So we could bring in the cartographic text as well. We'll hit OK. I'll just let that roll away. It's quite a big area this, so there's going to be I don't know, 30,000-40,000 entities that we're going to be bringing in. So immediately your brain will be sitting there going, my God, that's a lot of information I'm bringing into my DWG before I even start. So what we're going to do is I'll just show you that you can, and then we're going to do it in a far more efficient way. And using the power of the of technology, I'm going to pause this because it might take about 3 or 4 minutes, and you don't want to be sat there waiting for 3 or 4 minutes. And there we go. And that was 112,000 objects, so it's quite big. If I just take topographic area, or that one there, and refresh that, update, we should end up with some colours. And there we go. So we've got an awful lot of mapping data in there as well. And I've just updated the cartographic layer as well, and we've got the text in there. So there's an awful lot of stuff going on in there. Now if I was to look at one of these, the properties of this polygon here, you'll see we've got all this data down here. So it's telling me what it is. It's a building. Obviously it's man-made. If we were to look at this plot of land here, we can see it's under general surface, but that's man-made. So it shouldn't really be green. This one here, general surface natural. So clearly that's a car park, and that makes absolute sense. And we could just colour it and change its fill colour, couldn't we, and just manually edit that to whatever colour we wanted to. White would be a bit daft. Let's just make it a kind of grey colour, like so. So you can work with this data, but it's big and it's clunky. So we're going to show you how you can work with it in a far better way. So in this example, we're going to work with shape files or geospatial files. Now if we have a look at the data link here and connect to data, you've got all these different ways of connecting to data. Now think of it like an XREF, but cleverer than an XREF. So if you are an organisation such as a local authority or the police or anything like that, then you'll probably have ArcGIS, which is Esri's database connection. And ArcGIS, you just need to speak to your GIS team to get the credentials so that you can then connect either to a personal geodatabase, which is basically a file, or SDE Enterprise, where you can put your server in, and that will give you a permanent connection to all of the geospatial data that you have in your organization. Similarly, you've got ArcGIS Online, you've got an enterprise model here, we've got Oracle, we've got SQL selection, or MySQL open source stuff, Postgres SQL, so that's your PostGIS. If you hear PostGIS, PostGIS is an add-on to Postgres SQL, which is an open source one. A lot of local authorities have gone onto that now because it's free, which is good. Raster images, so raster files can be either landform or they can be an image, so we can connect to them, and we can connect to file-based systems. SDF is Autodesk's file-based system, Shapefile is Esri's file-based system. We've got SQ Server Spatial, which is a database again, where you need the service name and the data store. SQLite, that is it's a database, but again it's a file-based database, and there's quite a few products work on SQLite, including Infoworks. And then you've got web mapping services, WFS. WFS is Web Feature Services, so that is lines, arcs, circles, so it's vectorized data but on a web service. And web mapping service is rasterized data on a web mapping service. I know it can get a bit confusing though, because people will often use vector data on a tile cache, which comes back as like raster images. But this is what this one is. This is the new web mapping tile cache services, and that's been added in 2021. We have here shapefiles. This is the most common file you're going to get, and there's my master map topography in building layers, and you can see it's still quite big, a little bit bigger than the raw data was in its compressed format. And we can either go the long way and go shape connection and go and find a folder full of shapefiles, and it'll add them all in one go, or an individual shapefile by clicking that, or you can be a little bit cannier because it'll just drag and drop straight in. My zoom extents, there it is. It's exactly the same data, it's about the same size, and there was no need to pause there. It didn't take 3 or 4 minutes to come in. It comes in as one colour to start with. We can look at how to colourize your GIS data in a moment, but if we go and have a look at the data, connect to data, it's added that connection for me automatically, like so. Now we have this data, we can do clever things with it. I'll just create another map. You can create multiple maps in here, so I'll just duplicate that one, and I'll just call this one landline, like so, because what we might want to do is not show the colours. So we could say in here, in the style, because we can style it however we want, and we can say don't bother putting a fill in it. Okay, and now we have just the landline mapping, but I can go back to the original and flick between them. Let's duplicate that one again, and maybe you'd want to do a coloured map. Okay, so in this case we'll style this one up and we'll use a theme, because what we've got here is a data table. We just minimise that. And that data table has all them data attributes that I showed you when we imported the data. It's much cleverer though. I can zoom around on it, or I can pick data in here and it will zoom me to it in the table. So we could use this descriptive group to style it. So I could use a style here, and rather than just picking a colour, I'll use a theme, and I'll say use the descriptive. We could just set it to a ramp or whatever, but I have created on the polygons a palette called Master Map Sample, and that will colour it up nicely for me. You can create your own palettes as well. Where was that area that we looked at before, that car park? It was by the railway, wasn't it? So it was up here, there it is. Okay, remember when we looked at that before, it was man-made general surface, and that one is not a man-made general surface. So what can we do with that? Well, in the style palette, you'll see what it's done is it's created a query. And for non-GIS users, queries are what we use all the time in GIS. So I'll pick a general surface and I'll just duplicate that, because at the moment it said if the descriptive equals general surface, make it that colour. What I could say is if descriptive equals general surface and make equals man-made, make it grey. So let's do that. So general surface, descriptive equals general surface, I'll just put a space and say and make equals, and I can get the value because you do have to, it has to be correctly spelt and the syntax and everything, so capital M for example, so I can just double click it and then I'll make them all grey like so. And I could, to be technically correct, and say and make is not man-made, is green, or you can obviously build up queries as much as you like in there. So that gives us a bit more information in there. We can also run queries as well. So if I was to go in here and do data connect to data, rather than add to map, you can say add to map with query, and you can run a simple query, or you can do multiple condition query, or you can do by location on a map. But if you've already, so if it's a big data set, that makes more sense to do that before you bring it in, because it'll just kill your system otherwise. Too much RAM needed. What you can do once you've brought it in though, you can query from here. So if I right click, query to filter data, and I could say, for argument's sake, just give me descriptive equals buildings. Okay, and again you've got to spell it right and put it in commas. You can validate queries here. So if I've got that wrong, maybe I've forgotten one of them inverted commas, it'll tell me there's an error. However, you've got to be careful, because if I spell it wrong, I put a letter in there that's not wrong and validate it, it'll say, yeah, that's a valid query. It is a valid query, but it's going to return no results because there is nothing called a building. So I'll get rid of that E and we'll hit OK. And what we should get back are just, oh look, I did it wrong after all. Let me go back in to query that data. I put an S on the end, didn't I? So it just shows you how easy it is to make a mistake. So be careful with that. Suddenly all the buildings come back. I should have done a new map at that point, shouldn't I? I'll just call this one buildings, like so. And there we are. Just bring the buildings in. Now that should match the map. If I turn that aerial map on, it should all be in the right place. There's no having to go and find it. And sure enough it is. All in the right place. And we can do queries on other things in there as well. Let's just go to the style manager and just delete all them rules so they all go back to a single colour. Because in the data table there's one there for, where is it, calculated area value. So show me where all the big buildings are. So we could style it based on calculated area size there, and maybe I'll just do a natural breaks, maybe 12 of them, and maybe go hit the polygon, select, oh I could just do a colour run, couldn't I? So I could say from, let's do more colours, and we'll go from light red to a dark red, like so. I'll let that colour up the buildings, and there we are. So we now have darker colours where our buildings are large and lighter colours where the buildings are small. Now, one thing I did promise in the introduction was about building heights, and you'll see there's no building heights in here. Now, the Ordnance Survey do provide the building heights, but it's done separately. So let me get that data up. It comes as a separate file, so I'll get the data up and we'll have a look at building heights, and I'm also going to use Infoworks. Here we are in Infoworks. The mapping data is in here, and all I've done to bring the mapping data in is I've brought it in as coverage areas. Go and see some of my Infoworks tutorials if you want to know how we did this. But I've done it as coverage areas, and in the style palette I've just got all the mapping styles, general surfaces, etc. And in the style rules I've got all them style rules with the same descriptions. Look, general surface and user data equals man-made. I used user data. You can actually update the schema to take into account all the master map stuff. I'll be doing that in a separate tutorial another time. But I just cheated and put it into user data and then told it to do that. So we've got our map. It's draped on a surface. I got the surface from the Environment Agency, from the EA. And what I want to do is I want to put the buildings in, but I want to put them in 3D using building height data. So let's have a look at what the OS provide first. Here it is, CSV, and I've just opened it up, and there it is. So we have in here a CSV file that comes with that data, and it's got a OS topo ID, so that's what we call the TOID. And there's a problem with that because it's formatted differently. I don't know why they do this. There is a reason. There's always a reason, isn't there? But we need to reformat that. That's okay, we can do that. Then we've got a version and a date and all sorts of extra information. It's this stuff here that's important. Okay, so you've got absolute height minimum, absolute height H2 and absolute height max. So that is from sea level. So if it's a level 30, the building, that absolute minimum will be 30 if it's 30 meters above sea level. Absolute H2, that's the eaves of the house. So if that is 10 meters tall, that will be set at 40. And then absolute maximum, that's the highest point that they can find on the building. It's using an algorithm. People aren't going out there measuring all your houses. It uses LiDAR data and an algorithm to try and work out what is the height of a building. It's a lot harder than you think. Then you've got relative H2, so that is the height of the eaves minus sea level, so relative from the ground. So if it's a 10 meter eaves, that will be 10 meter, and then relative for the maximum height of the building. Okay, so they're the ones that are important really. If we drape the buildings on the surface and set the eaves to rel H2. So let's have a look at doing that. First things first, if we have a look at our TOID references, I've just reordered these here. You can see that they're preceded by 000, and here they're preceded by Osgb. So we need to change that to match. There is another issue as well actually, and we're going to ignore this issue for now. You need to work out how to handle that, but there are some that are preceded with 5 and some that are preceded with 1. And I've checked the specifications and I cannot for the life of me find why that is. My thought at this stage is that they're all new, these ones down here. Not all of them was restructured, but they're all generally new, so it might be something to do with that. But also it could be to do with the level at which they're on, because they all seem to be part of other buildings. So maybe that's I don't know, something sticking out at level 1, but they're all like that. And certainly there's one along the railway which is above the railway line, so that would be level 1. So these sort of things are not obvious there. This one here, if I have a look at this one here, that's actually the railway line here, so this could be a building that's above the level. And I think that's a 1 as well. There we go. So I'm going to ignore them. So let's just not worry about that for the moment. Let's see what result we get. And if we're happy with that result, we'll move on. So let's just deal with that Osgb. The simple fix for that, I guess, is Control H, find OSGB, and replace with, is it 4 noughts we want, or 3 noughts? 1, 2, 3 noughts. And replace all. And then we'll do a save as. And I'll just call this one formatted .csv. I'll do it. I've already done one. I'll do another one. Okay. Now you can use text files or CSV files for ODBC, but actually I'd recommend you use Access or something, a database. It's far more reliable. You've got better control over what all these columns are. So in this instance I'm going to use Access. I just simply imported that CSV file into Access, and then we can make sure that all the data columns are correct. But I'll show you how to use ODBC on any of them anyway. So we just do ODBC. Make sure you pick the 64-bit version if you're using 64-bit software, and we will just add one in, and you'll pick them in here. So if you're using CSV, you use that one there. You just click Finish, give it a name, SX building height, so I'll just call it SXBH. And you don't use the current directory, you go and pick where the file is, CSV, so it's in my data folder, in my Ordnance Survey, in my Exeter samples, and in my building heights folder. And it's, I think it's just in the root of that. Let's have a look. Options, it's CSV, define the format. No, it wasn't in there. CSV, it is. Oh, building attributes. That's why. There we are. It's there. Okay, CSV, and you can go in here and you just need to tell it what's what. The key thing is make sure that the toid is a character. Modify, and make sure these are numbers. ABS, max, and what have you. I have to say though, you'll find that far less reliable than if you use something like an Access database. So I would suggest you do that. So if I just go and pick an Access database, I've already got one, so I'll add one in and I'll do another one. So in this case it's an MDB file, and I'll just call it EXBH. I'll go and select the database, and it's already in there, so there it is, and that's it. You can see I don't have to worry about the formats in this way, it's already done for me. So I'll hit OK. So I've got one there called EXBH, so we'll leave that open and we'll just go in and have a look here. So if we go data, connect to data, and pick ODBC, and it should be in this list now. There it is. Test the connection. It'll always come up with a username and password. If you've not set one, just click login. It's fine. There it is. That's all done. So I'll just connect to that data source. It's in there. There's no X and Y, and I don't have to worry about coordinates at this stage, because all I'm going to do is I'm going to join it to this data, which has got coordinates on it. So I just need that toid to match whatever I called it in the database. OS Topo Toid Map 3D. There we go. I left the original one in, you see. So let's do that. We'll create a join, and we'll go and pick the ODBC, and we'll pick Toid and that OS Map 3D Toid. We'll keep all the records. And now we should have building height information. There it all is. Okay, so each building's got a height. So if we have a look at, say, One that I know is quite tall, this one here. So now we have a bit of data called Exeter Sample and Rel H2, and we know that that building's 30 metres high. Cool. So to get this into Infoworks, we need to export it. And the nice easy way is you can just right click and export as SQLite, because it will only export what we're seeing here. It won't export all the stuff we've queried out, which is perfect. So export data to SQLite, and I'll just stick it in a folder on my H drive. I'll put it in my work folder, and I'll put it in a Great Tech University folder. Ordnance Survey, oops, data, there we are, SQLite. All done. So we can shut that down, we don't need that. And we don't need that. And all we need to do is add it into here, into our data sources. So let's go and find that file. So I put it into, I'll get rid of that. And I'll just have a look at my other screen here. There it is. And there's the SQLite file. Just drag and drop that in. All we need to do is tell it that they're buildings. And we need to tell that their roof height is a relative H2. There it is, relative H2. We need to make sure it's on the British National Grid. It is. We need to make sure they're draped on the surface, and we'll clip it to the model extents just in case it is big. I don't think it is, but it might be. And let's go with that. Perfect. And there's all our building heights in. Top tip here, if you want them white, because it's really hard to get them white, look, if I go select all features and change the colour, you see there's no style on the manual style. There's a base colour here, should I say. I'm going to go white. And roof material, I'll just put that as white as well. They're not white. You're like, oh, why is that? That's okay, because in the model properties, no, I didn't mean that. I meant in there, the model browser, what you could do is you could pick the buildings and you could make them so you can set the highlight colour, and I can set the highlight colour to white and then highlight them. Oh, white, maybe not that white, it's a bit too white, isn't it? Set the highlight colour, let's just bring it down a few notches. I know it looks grey in here, still too white. And there we are, much whiter buildings in here. I'd say that's probably still a bit too white, don't you? Doesn't feel like that, but there we go. Close that down. So that's how you get your buildings into 3D. And that's it, we've run out of time. Blimey, that flew by. If you want any more information on using Ordnance Survey or any geospatial data, just give us a shout. We'll gladly come and help. And it's time now if we have any questions, I guess.
Sorry.